Bosch ABS3, Bendix Antilock 10, Bendix Antilock 6, R-Wall. Over the years, MasterTech has introduced you to a number of anti-lock braking systems. And if you saw the Neon Highlights program, you know that there's a new anti-lock system, ABX4. Welcome to MasterTech release number 2. With the number of anti-lock braking systems in current and previous model Chrysler vehicles, it's important to keep track of the similarities and differences in the systems. For example, ABX4 is similar to Antilock 4, which you may already be familiar with. However, there are important differences which we'll be examining in this program. More specifically, we'll be covering the locations and functions of the components used in ABX4, system operation, and diagnostics. Then we'll put this information to work to find the cause of a diagnostic trouble code and conclude the program with a look at some service items. The base brake system on a Neon with ABX4 functions in the same way as the brakes on a non-ABS Neon. However, there are a few differences in the base brake system components. The master cylinder on ABX4 Neons uses a center valve design to control the flow of brake fluid. The vacuum booster is different as well. A tag on the front face identifies booster application. The sales codes on the tag are related to the general configuration of the brake system. In addition to the 13-inch front disc rear drum configuration, as the model year progresses, a 4-wheel disc and a 14-inch front disc rear drum configuration will become available. This affects parts applications, so be sure to match replacement parts to the Neon you're working on. As in other anti-lock systems, the proportioning valves are located on the hydraulic control unit. The anti-lock brake controller, also referred to as the cab, is located under the left side of the instrument panel. As with other systems, one of the controller's jobs is to determine when anti-lock braking is required and to regulate brake pressure accordingly. The controller also performs a number of diagnostic functions, covered in detail later in this program. If the controller can be considered the brain of the ABX4 system, the hydraulic control unit, or HCU, is its heart. The HCU, located under the master cylinder on the left frame rail, contains a number of components which operate during an ABS stop. The hydraulic control unit includes 4 Decay solenoids, which allow the controller to reduce pressure acting on the wheel brakes. 2 sumps, which receive fluid from the Decay solenoids. 2 pumps, one on each side, driven by a single motor, which allow pressure to build at the wheel brakes. And 4 shuttle valves, which control the build pressure provided to the wheel brakes. The ABX4 system does not use high-pressure accumulators. Mounted on the HCU is a relay box containing the system relay and pump motor relay, both of which are activated by the anti-lock brake controller. The system relay provides power to the Decay solenoids and the pump motor relay coil. The pump motor relay provides power to the pump motor. The relay box also contains a diode for ABS warning lamp operation, which we'll discuss later. The ABS warning lamp is located in the instrument cluster. Its job is to warn the driver of an ABS malfunction. The red brake warning lamp indicates parking brake application or a malfunction in the base brake hydraulic system. By the way, the Neon base brake system doesn't use a pressure differential switch. To warn of low brake fluid, this system uses a low brake fluid level switch located on the master cylinder reservoir. Besides illuminating the stop lamps, the stop lamp switch provides an input to the anti-lock brake controller. This input helps the controller detect impending wheel lock earlier. As you know from studying other 4-wheel anti-lock brake systems, the controller detects impending wheel lock through tone wheels and wheel speed sensors. And as with most other anti-lock systems on front drive vehicles, on the Neon, the front tone wheels are part of the outer constant velocity joints, and the wheel speed sensors are mounted to the steering knuckles. The rear tone wheels are part of the rear hub and bearing assemblies. The rear wheel speed sensors are mounted to the brake backing plates. Next, we're going to look at some features of ABX4 operation. But before we do, try this review question. Which of the following components is not located in the hydraulic control unit? A. Decay solenoids. B. Pump. C. Fluid level switch. Or D. Shuttle valves. The answer is C, the fluid level switch, which is located in the master cylinder reservoir on both non-ABS and ABS-equipped vehicles. The components we've looked at operate together to prevent wheel lockup during heavy braking. The anti-lock brake system helps maintain directional stability and at the same time allows the driver to steer the car. To get a better idea how the ABX4 system operates, let's look at controller operation, beginning with controller power and grounds. The ignition switch provides power to the controller through fuse 10 in the fuse block. When the controller energizes the system relay, this fuse also provides the controller with power for the decay solenoids. By the way, the system relay also feeds the pump motor relay coil. However, the controller must provide a ground for this relay to energize. We'll cover relay operation in greater detail later on. We mentioned grounds. That's because the controller actually has two. Besides a case ground, the controller also grounds to the left radiator closure panel, the same as the left headlights. From our discussion of the ABX4 components, you probably have a good idea of at least some of the controller inputs. They include the signals from the individual wheel speed sensors and a stop lamp switch. The data link connector input allows communication with the scan tool, and the pump motor monitor allows the controller to check the pump motor operation. We already mentioned some of the controller's outputs, although we didn't specifically refer to them as outputs. They include power for the system relay, and a power circuit for each decay solenoid, a ground for the ABS warning lamp, and a ground for the pump motor relay coil. The data link is also an output. In fact, it is a bidirectional circuit, which it shares with the data link input. The discussion of controller operation probably gave you a rough idea of how the system and pump motor relays operate. Now let's examine their operation in greater detail. Warning lamp operation is closely related to the relays, so we can look at it as well. Once it has received power through the ignition switch, the controller sends power to the system relay coil, which is grounded at the left radiator closure panel. The switching of the relay contacts provides power to the controller through fuse 10 for decay solenoid operation. It also provides power to the pump motor relay coil. The pump motor relay coil receives its ground from the controller during anti-lock braking. The coil switches the relay contacts to provide power to the pump motor through a 40-amp maxi fuse in the power distribution center. Notice the circuit returning to the controller from the pump motor circuit. This is the pump motor monitor we listed earlier as an input. If you've studied similar anti-lock brake systems, you've probably got a pretty good idea how the ABS warning lamp works. The lamp is provided with power through fuse number 11 in the fuse block. The controller can provide a ground for bulb checks or to warn of a system malfunction. The diode in the relay box prevents a short to ground in the event the system relay is energized while the controller is attempting to provide a ground for the lamp. The warning lamp can also obtain a ground through a de-energized system relay. This provides a warning in the event the controller does not provide a ground for the lamp. Compared to hydraulic control units used in other anti-lock brake systems, the ABX4 HCU is simple in operation. When activated by the controller for anti-lock braking, the 4 Decay solenoids interrupt brake pressure and route fluid from the wheel brakes to the sumps. One thing to keep in mind about Decay solenoid operation is that while the front solenoids are controlled independently, the rears are controlled together. The solenoids are grounded at the left radiator closure panel. The HCU motor uses a cam to drive 2 pump pistons. Tuning chambers dampen the pump pulses. As in other systems, the diagonal split of the base brake system is also used to divide the anti-lock braking system into a primary and secondary side, with corresponding sumps and pumps. As mentioned earlier, the shuttle valves control the build pressure provided to the wheel brakes. Sometimes this involves controlling pump flow to both the wheel brakes and master cylinder. At other times, the shuttle valves control flow from the master cylinder to the wheel brakes. Pump pressure overcomes spring pressure to move the shuttle valves. The pump is activated any time anti-lock braking is required. Once it reaches the shuttle valves, fluid from the pump passes through a series of orifices and check valves. These provide the wheel brake with regulated amount of fluid when the Decay solenoid is de-energized. If the Decay solenoid is energized while the pump is activated, brake fluid from the pump is diverted to the master cylinder through the shuttle valve. The check valves and orifices also control fluid flow to and from the master cylinder, which affects pedal movement. Now that we've seen how individual components operate, let's look at the sequence of events as ABX4 operates to counter impending wheel lock in a left front wheel. The left front wheel speed sensor indicates excessive deceleration of the wheel. As a result, the controller determines impending wheel lock at that wheel and activates the Decay solenoid for the left front wheel brake. Once the Decay solenoid is energized, the left front brake is isolated from master cylinder pressure, and fluid from the brake is routed to the sump. At the same time, the controller energizes the pump motor, which pressurizes fluid from the sump and sends it to the left front shuttle valve. The left front valve moves against spring pressure. While the Decay solenoid is energized, fluid is diverted back to the master cylinder at a controlled rate through the shuttle valve. As a result, the brake pedal rises slightly. As the left front wheel recovers from the impending wheel lock, the controller de-energizes the Decay solenoid. As a result, pressure is increased at a controlled rate through the shuttle valve to the left front brake. This pressure can come from both the pump and the master cylinder. If the master cylinder provides fluid, the brake pedal falls slightly. The controller continues to rapidly energize and de-energize the left front brake solenoid until the threat of wheel lock is over. At this point, the controller shuts off the pump and the left front shuttle valve returns the left front brake to master cylinder pressure. No discussion of anti-lock operation would be complete without mentioning what your customers are likely to hear and feel during an ABS stop. One sound they may hear is the pump motor. It may continue to be heard briefly after an anti-lock stop. Customers may also hear clicking and popping noises as the controller modulates pressure during ABS stops. Pedal pulsation is also a normal part of ABX4 operation. Pedal pulsation results from pedal rise during decay and pedal fall during build. Keep these normal operating characteristics in mind if a neon is brought in with a complaint of noise or pedal feedback during ABS braking. And now, before we move on to diagnostics, let's try another review question. The pump motor relay coil is energized anytime it is provided with A, power from the controller, B, power from the system relay, C, a ground from the controller, or D, power from the ignition switch. The answer is C. Although the relay coil receives power from the system relay, It is not energized until it receives a ground from the controller. As mentioned at the beginning of the program, the anti-lock brake controller performs a number of diagnostic functions. These can be divided into monitoring that occurs at startup, monitoring that occurs at about 8 miles per hour, and monitoring that is continuous. When the key is first turned to the run position, the controller checks the warning lamp circuit, lamp diode, pump motor circuit, and system relay. It also checks itself at this time. This is known as the startup cycle. The warning lamp illuminates for about 2 seconds while the checks are being made. The monitoring that occurs at about 8 miles per hour, referred to as the drive-off cycle, takes place the first time the vehicle reaches this speed during a key cycle. At this time, the controller cycles the Decay solenoids, briefly runs the motor, and checks the wheel speed sensors. If the driver has his foot on the brake when the drive-off cycle testing is to occur, the check is not run. Items that are continuously monitored include the wheel speed sensors, pump motor circuit, and voltage supply. The controller also continuously checks itself. If self-diagnostics reveal a problem in the anti-lock braking system, the controller shuts down anti-lock braking and stores a diagnostic trouble code. Base braking is not affected. The 16 diagnostic trouble codes are listed in the Diagnostic Procedures Manual and in the reference book accompanying this video. There are 2 general types of codes, latching and non-latching. When the diagnostic trouble code is latching, even if the trouble has disappeared, anti-lock braking remains disabled until the next key cycle. After the trouble disappears, the code remains in the controller's memory for about 50 key cycles. An exception is the controller trouble code, which must be erased with the scan tool. Solenoid undervoltage, a non-latching trouble code, also remains in memory for about 50 key cycles after the trouble disappears. However, unlike latching faults, if the trouble disappears within the key cycle, the controller can restore anti-lock braking and extinguish the ABS warning lamp. Under certain conditions, a code can allow limited ABS operation or result in the warning lamp being shut off. For example, if a wheel speed sensor signal is missing for more than 2.5 seconds during an ABS stop, rear anti-lock braking is still allowed, even though the warning lamp is illuminated. And full anti-lock braking is restored and the warning lamp extinguished if the condition disappears at the end of the stop. We mentioned that the Diagnostic Procedures Manual lists the diagnostic trouble codes, but it also points out when circuits are monitored and how codes are set. In addition to its description of codes and system operation, the General Information section details component location and identifies terminal locations. Like other diagnostic manuals, most of the general troubleshooting section is divided into procedures which correspond to a particular trouble code. Be sure to perform the steps in Test 1A before proceeding to the other tests. One of the steps allows you to determine if the stop lamp switch is providing an input to the controller. This is important since the controller does not store a code if this signal is missing. Like the Diagnostic Procedures Manual, the drbIII scan tool is an essential piece of diagnostic equipment. When you watched last month's program, you learned about some of the features of this new scan tool. When you use it on ABX4, this scan tool can provide you with a lot of information. Under Read DTCs, you can, of course, retrieve and erase diagnostic trouble codes. Codes can also be erased with a selection we'll be covering later. Under Sensor Display, you can obtain wheel speed sensor readings in miles per hour, as well as voltage readings for relays, the stop lamp switch, and the warning lamp. With the Inputs-Outputs display, you can tell whether a number of components are on or off. This selection can also indicate whether solenoids are in a build or decay position. Under Actuators, the first page allows you to activate the warning lamp. system relay, or pump motor relay, individually or all at once. It also allows you to activate individual Decay solenoids, while the second page, hydraulic actuators, includes solenoids and pump motor operation, so that you can simulate anti-lock braking in individual brake circuits. Remember when we told you that diagnostic trouble codes can be erased using a different selection than read DTCs? It's here under Miscellaneous. Also located here is a bleed brake selection, which we'll talk about when we discuss service. The data link connector is located under the instrument panel near the steering column. It's the new type of connector required by the OBD2 Diagnostics, which we discussed last month. Next, we'll cover using the drbIII scan tool to find the cause of a trouble code. But before we do, you guessed it, another review question. You may want to look at the General Information section of the Diagnostic Procedures Manual to help you with the answer. Which of the following trouble codes might accompany an ABS warning lamp that blinks intermittently during a key cycle? A. Modulator circuit. B. System relay circuit. C. Pump motor circuit. Or D. Solenoid undervoltage. The answer is D, solenoid undervoltage. This is a non-latching fault. As a result, it's possible for the warning lamp to go out and come back on again during a key cycle. At this point, let's use what you've learned so far to troubleshoot an ABX4 system that is not working properly. As we troubleshoot, we'll be using the 6-step troubleshooting procedure as a guide. A neon comes in with the ABS warning lamp illuminated. The complaint can definitely be verified. According to the customer's description, the warning lamp came on intermittently and then remained on. The diagnostic manual lists a visual inspection as its first step in Test 1A. The inspection allows us to quickly isolate and repair any obvious trouble. Next, we hook up the drbIII scan tool to the data link connector under the steering column and run a brake switch test. We mentioned the reason for this test earlier. The anti-lock controller does not check the brake switch circuit and will not display a code if this switch is not working properly. The next step, a check of diagnostic trouble codes, reveals a solenoid undervoltage condition. We look for related symptoms in the form of other trouble codes, but there are none. So we proceed to test 5A in the manual to isolate the trouble. The first step in test 5A is to verify the condition still exists. To do this, we access read DTCs with the drbIII scan tool. Erase the code and cycle the ignition off, then on. Then, after actuating all outputs, we read the diagnostic trouble codes, and solenoid undervoltage reappears. With the condition verified, the diagnostic manual directs us to the relay box connector, where we can start isolating the trouble. The first step is to disconnect the connector for a visual inspection with the key off. There are no damaged terminals or pushouts, so we start checking circuits. The first of which is the ground for the system relay coil. The scan tool shows continuity to ground at terminal 10. The ground is all right. The next step is to turn the key on and check the ignition circuit at terminal 5 of the 10-way connector. Besides providing the controller with ignition voltage, this circuit supplies the switch side of the system relay, which goes on to supply the solenoids and pump motor relay coil. The ignition circuit is good. So the next step is to check the system relay control circuit for voltage. As you may recall from the discussion of system relay operation, this circuit from the controller provides the system relay coil with voltage. To check it, we activate the system relay with the scan tool while probing the system relay control circuit at cavity 2 in the 10-way connector. Instead of toggling between 0 and over 10 volts, the reading is 0. The circuit is failing to provide voltage to the system relay coil. It's time to go to the controller 60-way connector to find out why. As with the 10-way, the first check involves turning off the ignition key and making a visual inspection of the 60-way connector itself. In this case, it looks all right. The next step is to turn the ignition on and check for ignition switch supply voltage at the 60-way. Without this, the controller can't supply voltage to the system relay coil. Probing cavity 60 yields battery voltage. The voltage supply is okay. So it's time to turn our attention to the system relay control circuit. If you remember, we failed to find voltage in it when we checked it at the 10-way. In making our first check for a short to ground, the 10-way is still disconnected and the ignition is off. We probe cavity 57 in the 60-way with one lead of the scan tool ohm meter while grounding the other lead. Resistance is infinite in this case, so the circuit is not shorted to ground. Time to check it for an open. To do this, we reconnect the 10-way and once again probe cavity 57 with an ohm meter lead while connecting the other lead to ground. Resistance is still infinite. With the 10-way connected, this indicates an open in the system control circuit. Upon examining the control circuit wire, we see that it's broken. That brings us to the final steps of the 6-step troubleshooting procedure, repairing the trouble and verifying the repair. After soldering the wire ends and protecting the splice with shrink wrap, we proceed to the verification procedure in the diagnostic manual. With the 60-way connector reconnected, we now turn the ignition on again, then actuate all outputs for 15 seconds, and each hydraulic circuit for 10 seconds. After accessing the diagnostic trouble code selection, we failed to find any trouble codes present. The repair is complete. Next, we're going to cover a few service items you'll need to keep in mind when working on the ABX4 system. But before we do, let's try another review question. What is the purpose of the highlighted circuit between the anti-lock brake controller and the 10-way connector? The highlighted circuit is the system relay control circuit. It is this circuit which provides voltage to the system relay coil. In this segment, we're going to look at a few service items on Neon ABX4. Some of these are the same as on earlier systems and bear repeating. Others are unique to ABX4. First of all, since the Neon anti-lock system lacks high-pressure accumulators, you do not need to depressurize the system with the brake pedal to check the brake fluid level in the master cylinder reservoir. The fluid level should be between the minimum and full marks on the reservoir. And by the way, use only brake fluid that conforms to DOT3 specifications, such as MOPAR brake fluid. If you've bled the brakes of vehicles with Antilock 4 in the past, you're going to notice some changes with ABX4. As with Antilock 4, the first step is to bleed the base brake system. Unlike Antilock 4, on ABX4, base brake bleeding can be done manually or with a pressure bleeder. After bleeding all 4 brakes, you need to bleed the HCU. This is easy on the ABX4 system. With the scan tool, simply access Miscellaneous under the ABX4 selection and initiate bleed brakes while maintaining firm pressure on the brake pedal. There are no HCU bleed screws to open and close. After this, you'll need to bleed the base brakes again to work out any air expelled from the HCU. If there is a lot of air in the system, you'll need to repeat the bleeding procedure until all of the air is expelled. Keep in mind that bleeding the HCU is normally not necessary after base brake system repairs. Usually it is necessary only when the HCU is replaced. And speaking of HCU replacement, there are a few service items to help ensure the system is repaired correctly. To remove the HCU, it's first necessary to remove the master cylinder. Before doing this, however, be sure to deplete the vacuum in the booster by pumping the brakes until you obtain a hard pedal. If you don't deplete the vacuum, it could suck contaminants into the booster upon master cylinder removal. The next item concerns the vacuum seal between the booster and the master cylinder push rod. This seal must be replaced any time you remove the master cylinder. To remove a seal that has remained with the booster, carefully insert a screwdriver between the vacuum booster push rod and the seal. Throw the seal away so that you don't reuse it. To ensure the new seal is installed correctly, be sure to follow the procedure in the anti-lock brake section of the service manual. The final service item pertains to the relay box on the HCU. Individual relays and the warning lamp diode cannot be serviced separately. The relay box is replaced as a unit. Now that we've covered some service items, try a review question to see how much you remember. When bleeding brakes on a neon equipped with the ABX4 system, the first step is to A. Access bleed brakes with the drbIII scan tool. B. Bleed the base brake system at the wheel cylinders. C. Bleed the HCU at the HCU bleed fittings. Or D. Pump the brakes until booster vacuum is depleted. The answer is B. Bleed the base brakes at the wheel cylinders. Then, if necessary, you can bleed the HCU using the drbIII scan tool. If you're familiar with other Chrysler anti-lock braking systems, you really shouldn't have trouble with ABX4. It's a relatively simple system, and diagnosis and service are fairly straightforward. The hardest part may be keeping track of the differences between its features and those of other systems. That about wraps up this month's program. We'll see you next month on MasterTech.